Hey guys, today I'm going to make a continuation video of the video I made yesterday on the Hammond organ clocks, or the Hammond clock company, should I say, not the Hammond organ. Same company, but these were before the Hammond organ. They actually were originally a clock manufacturer. So I recommend you watch that video before you watch this one. This will all make a little bit more sense as far as what I'm going to be talking about with this clock. And so we're just going to dive in here. So what I've done today is open up the other clock I had. This is the one that was actually running on the organ, but it was really struggling. It had issues starting it, and it had an issue where sometimes it would just stall. It'd be running and it would just stall out. And it's almost the same issue that old organs have when they've been sent around, which is the tonewheels get tight, and the synchronous motor just doesn't have the torque. It don't have the torque or the horsepower to keep that thing running. And so you'll lose, frequency and all that kind of stuff because that motor is under load. Same thing with these clock motors. They're synchronous motors, and there's just no horsepower in them. So you have to physically start them, and then once they're started, they should run as long as nothing's, binding or has a lot of resistance. So that's what was the death of these particular clocks, is that they didn't have basically oil. These motors are oil filled, and the oil turns to gel, and it just is too tight. It just cannot, it can't overcome the resistance in this the load in the motor. So what I did this one is I dissected this motor, and as you can see, this clock is actually running and it's keeping really good time now, even though I have the motor open, which I've been doing some testing as well, such as taking thermal readings with a thermal camera to see if the oil actually keeps the motor cool. Has no effect on the motor, so the motor doesn't care. It doesn't use the oil for temperature. But what I about came to the conclusion is the oil is in these motors just to give them a long lifespan. It keeps everything lubed up, and it does pull a little heat off, I'm sure. But most of the heat that you see comes off the transformer, the actual transformer that's converting 120 volts down to 6.3 volts AC. I have found out. I did some measurements on the actual plates. For that, if you look at this clock, it's these two plates here, which the motor's inductance. So the coil converts voltage down. It comes out on these two plates. It's 6.3 volts AC on these plates, and then it's actually being sent to this motor and its inductance. So this motor is actually sealed. There's no opening. It's actually just picking up that electromagnetic field into this motor, and that's what actually causes this motor to run. Really ingenious design, especially when you talk about 1930s, 1940s. So that's pretty cool stuff right there. But what's also really cool, since this clock here now runs, I've still got the motor open up, I can show you what this thing looks like running. So I'll pull this thing up here, and you can just kind of see I'm having issues with my lighting, so please forgive me here. I'm using my head strap light here, trying to get in there. But anyways, here's the motor. You can see the motor's opened up on this one. I got held in place with two packing peanuts just temporarily. And you can see the drive gear. There's your actual gear for the ratio change. And then here's your actual motor back over here. You can actually see the little flywheel and everything turning on there. If we turn it up over here, maybe you can see it. But that's the part that's actually like a tonewheel. It's just a reverse tonewheel. Instead of generating frequency by being rotated by motor, this is actually being excited by electromagnetic fields, and it becomes a motor. So pretty cool concept here. But you can just kind of see how that looks. It's driving the clock just fine. What I will do is I'll stop it right quick, and then we'll restart, and I'll show you kind of what this motor looks like. So what we'll do is actually I'm going to just push in on the start. You can see it's actually stalled out. It won't run. It won't self-start. But you can see now the motor, if we look down in there, maybe my camera will focus here. There it is. You can kind of see those teeth right there, which I have a better video yesterday on this. But you can see those teeth, which is actually kind of what's kind of like a tonewheel generator. So let me zoom back in here. I'm going to restart it for you, so you can just kind of see how this works. So let me get this clock wheel set up for me. So basically what you do is you push in on this, and you can actually start it backwards. So let me find the gear here. So you just give it a little turn, and the clock should start, and it does. and now it's running back on its own power. So anyways, that's how it works. That's what it looks like inside. But when I dissected this motor, I did learn something, and that is that it has a plug. There's a solder plug in right here. And so what I did to this next clock is actually I desoldered that plug instead of taking apart the whole motor. So just to show you the construction of this motor, I brought this up yesterday, but now you can see it. You can see that they actually have a flange, and they solder around the flange to hold, to make it, make it a sealed unit. So actually yesterday I desoldered all the edge around that flange and actually bent that flange out. So what I'm going to do is I'm actually going to put this back together. I'm going to put put a little bit of oil in it. Probably just going to put some kind of like really light, low viscosity oil. You don't want anything real heavy in these clocks. But I think mostly it's really to help the lifespan of the bearings and everything in the actual motor. It doesn't really do much for the cooling, like I say. But anyways, what I did to this one is I pulled that plug and I actually flushed it with WD-40. I used WD-40 to flush it out really good. Just show what came out of this clock. It's nasty. The liquid is actually WD-40. The green stuff that's like sediment is actually out of the clock. And it's just a really nasty smelling oil. It's the only way I know how to describe it, if any of you have ever smelt a burn-up transformer or overheated transformer, that's what this smells like. I'm going to give my buddy Derek Hatchell a call out here because he'll know exactly what I'm talking about. Where we used to work, we had one particular unit that would blow up on occasion, and it was always the transformer. And when it would go bad, it smelled like this. So that's the smell, Derek, just so you know. But anyways, that's kind of a look at these clocks and how they work, and just a really cool concept of how these work. And once again, you can kind of see the motor removed on this one, how it looks, and then you can see the motor all assembled on this one. Not taken apart, just had the plug pulled. So anyways, guys, just want to make a little follow-up video, and maybe this will help some of you guys out there that may have a Hammond clock you want to do a repair on. These are repairable. You just have to have a good hot high wattage iron to desolder this plug. And what I did to this one in particular, because it's hard to grab, so what I did is I actually desoldered it. I have a solder sucker, and so I heated it up with a high wattage iron, desoldered it with a solder sucker, and I took some wire cutters, some little small wire cutters I got, and actually grabbed on both sides of the plug, but you can see the plug here, and I just kind of pulled it up out of there while it was hot, and it worked great. So that's how you can actually service these clock motors. They are serviceable. And like I say, the oil I'm going to use is just going to be a low viscosity. You would probably be fine running it without oil. I've had that one running all this morning with no problems, taking temperature readings and stuff to see if the oil affected any of that. So I don't think you'd have to put oil in it, but I would recommend putting oil in it just to help save the bearings, because it's already lasted this long. We're talking 75 to 80 years here on these clocks. So it's pretty impressive that they actually still run. But it also shows the quality of Hammond products, including their organs. And before Suzuki bought them, that is. This is Hammond. So it's a really neat concept here. But the clocks that I've actually got here, these are the ones that look like Gothic clocks, I've heard them called. And this was the one I actually started with because it's got a crack in it in the bakelite. So I'm actually going to be repairing that. The other one, though, it's in really good shape. It's good and solid, no cracks. Just needs a good cleaning, that's all. But anyways, guys, just want to make a follow-up video. Thought you might enjoy this, seeing a little bit of what's inside the Hammond clock from yesterday, and actually seeing one in action that's actually been opened up. Just a quick update here. Got this clock reassembled. This is the one I pulled the plug on and flushed the motor. And actually what I ended up doing, I ended up using just some Hammond tonewheel oil. That's actually a pretty good viscosity. It's not real thick, not real heavy, and seems to do really good in this clock. So I did the same thing to this motor. This is the one I actually had dissected, and I went on and put some in it before I put it back together. And so re-crimped the edges and resoldered it. As you can see, it's all nice and smooth and resoldered. And we're going to see how that does. So hopefully this motor here still works okay. It still spins really free. I think we're going to be in good shape with it. Okay, and we have two working Hammond clocks here now. Just put this one back together. This one I disassembled the motor on. That's the one I actually just pulled the plug and cleaned it. So there they are, both running. Now these things will be coming back apart. I'm going to put new power cords on both of them. I've also got to fix the bakelite on this one. You can see it's actually cracked. But actually I can pull it back together. So I'm just going to clean it up on the inside and do a repair to that. But anyways, they're both running really good now. Both keeping time. And very happy about that. But anyways, guys, just want to make a little video here to finish this off. I know this is kind of a cut up video here, but wasn't sure if I'd get these things done today or not, or even if they'd work. But you can see I think one of these is newer than the other. This one here looks older for some reason, just the badging on it. Serial number on this one is let's see, 210308 is the number on this one. This one here is 111957 is the number on that one. So not sure how to identify these things as far as age goes, but they're both old, I'll tell you that. You can see the cords definitely need to be repaired, but that'll happen here in the very near future here. But just go this way with it. Also I got to do a little work to this one just because the glass is kind of loose in it, so I have to do something there. But anyways, there they are, both running. Appreciate you guys watching. Take care.